Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 59. Number of ways to separate numbers. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and so forth. But also, if you had trouble with it, come to our Discord. Come hang out, come chat about problems. People did solve it and people were talking about it. So this one is a very, very hard problem. I actually didn't solve this during the contest, though I think I was very close. If you watch my video afterwards, you'll see that I actually was relatively close, but I had some issues with, short answer is that I spent too long on Q3, so I ran out of time for Q4. But I'm going to go through the progression of my thought process and how to kind of, instead of just showing you a solution, going through how I move toward optimizing it to get a right answer. So, okay. So number of ways to separate numbers. So this one, the first thing to notice is that n is less than 3,500. This is actually really sketchy because in Python, it's kind of really slow. And I actually ran the tests, and in the worst possible case is not actually in the inputs during the contest. I don't know why that is, but if that is in there, my code actually still kind of times out, and I have to do another optimization. But for now, we'll go over what does work on the current Leetcode judge. So the first thing to notice is that if you do recursion, there are only two scenarios, right? The first thing that came to my mind is dynamic programming, and the idea behind this dynamic programming is that, okay, let's say you have this number, right? Like I said, there are only two. You think about it as a decode ways or whatever, where it's just you have a number and you're partitioning in some ways. Whoops, right? Of course, if you do it naively, it's going to be n cubed or at least n squared or something like that, right? But the thing to note about this problem is that once you're able to think about this way, there's one observation, right? Which is that if two adjacent numbers have if we're going in a non-decreasing order, that means that between two adjacent numbers, what does that mean? That means that there are only two scenarios, right? One is if they do not have the same number of digits. Well, if the number of digits on the, you can see really easily that the number of digits on the later number has to be bigger than the number of the smaller digits, right? Or the one on the left. Because if it has smaller number of digits, then, well, that's a smaller number, so there's no way of doing it. However, if they have the same number of digits, then you have to do that's when you have to check to see if the two numbers are smaller or greater than or equal to, right? Otherwise, if there are more numbers or more digits on this second number, then you are able to you can go without checking digits, and that makes it a little bit faster. So okay, so that being the recurrence, then now we can think about the states in a little bit cleaner way, which is that, okay, we can track how many digits are in the previous number, right? And if, previous digit, and that means that now for the next digit, we just have to iterate from the previous digits and up, keeping in mind that if it has the same digit, we have to do a check. Okay, I hope that makes sense so far. If it doesn't, then I hope you go work on dynamic programming problems. That is, partitioning a number or a string and counting the number of ways. Definitely try to go about that. And this is just that problem, except for one step harder. I'm not going to go with that particular part. This is a very hard problem, so I'm not going to go over the basics of dynamic programming in this video, because this is going to be a long enough video as is, right? I hope that makes sense. But yeah. So you can think about maybe another similar problem you can think about is like decode ways, I think someone mentioned, or just like string partition or something like that, right? So look through those problems if you have trouble with that. And once you do, then here for this problem, you have to add a dimension or add a state, which is the number of previous digits, which is the thing I have here. For me, I changed what I said here with the visualization. What I did was I actually have a function that counts smaller, and I actually did the index backwards. So now instead of going, so this actually, you know, the problem is the number of possible lists of integers of num from the beginning. So this is a prefix of prefix string num of decreasing value or non-increasing. So monotonically decrease, monotonically can't spell, so let's just say non-increasing, right? Because now basically what I'm doing here is that I'm going backwards, and then here we can think about and I already did the memorization. The reason why I did this instead of say cache is because actually this is much faster, and for n is equals to 3500, we need every speed that we can get. Okay, so here if index is 0, that means that we've reached all the digits from, so we're going backwards from n. Let's actually go to our starter. So if the first digit is 0, there's no possible path, so we save some time that way. Otherwise we go, okay, for the first digit or the first number in the list is of size of length x, we go, okay, let's count the smaller of the x and n minus x, and then, you know, you just do the mod thing here. Yeah, so this is, oh yeah, let me add where the last number is of contains upper digits, right? And in this case, then, okay, if we used all the numbers where index is 0, we return 1. If we can cache it, we cache it, or we return the cache. If the first digit is 0, we return 0. This makes sense because there are no prefix zeros. Otherwise, if there are no digits left, then we use 0, right? Because basically you cannot use any digits because there's no digits in the previous one. And this algorithm is a very slow one. We'll talk about optimization next, but in this case, let's see, right? Upper can go from 0 to n, so this is O of n. Index can also go from 0 to n, so this is also O of n. So that means that there are O of n squared possible inputs, right? In this case, however, that doesn't mean the complexity is n squared. It just means that there are n squared possible inputs. In this case, we upper bound, okay. Let's just say we brute force iterate all possible numbers for next number, right? And here what we do, and this looks a little bit yucky, but you can imagine, yeah, if this is just, you know, next number will have x number of digits, right? So that means that here, let's skip the if statement for a second. Here, that means that, okay, if the last number has upper number of digits, I use upper for upper bound. If the last number has upper number of digits, then there are only two scenarios, right? One is if they have the same number of digits. If they have the same number, or if they have a fewer number of digits, then we go to a recursion. And this recursion is just, okay, now we have x number of digits, we chopped off x number of digits off the index, so then we go, you know. And I hope this part makes sense. And then the other one is if this case, which is that if they have the same number of digits, then we want to check to see that we want to see that I guess technically actually this is upper, but well, this should be the same, but yeah, if they have the same number of digits, then we just want to make sure that the number is smaller. If the number is smaller, then again we do recursion. Okay, so what is the complexity here, right? This has O of n loops, and this, right? So because this has O of n loops, this is going to be, and there's this if statement here. Of course, this doesn't happen n times. This only happens once. This happens exactly if upper is equal to x. So let's actually rewrite this slightly. If so, we can say if x is less than upper, then you do this thing, right? Or else if this thing, that because x is equal to upper, and this thing, so this is a rewrite of that. And in this case, you can see that this only happens once, which is if x is exactly upper. So even though this takes O of n times, this only happens once, right? So that means that this is going to be O of n plus O of n. So this is O of n total. So that means that for each possible inputs, we do O of n work, right? So that means that total complexity is O of n cubed, and total space is O of n squared. But I think that's more obvious because you have the cache here, right? So then the question is, of course, this is too slow. You would submit it and you get a TLE, right? Time limit exceeded. So what do you do? So the next thing you can think about is optimizing this in one way. So the thing that I notice is that, okay, because in this case, we noticed that for the smaller case, we actually don't have, you can think of this as a prefix sum. And how do you think about it as a prefix sum? Well, because this is yeah, so you can think about this as a prefix sum because this is always going to be true, right? So the way to think about it is just that this is a prefix sum, and as such, then yeah, you can think about it as a prefix sum. So that you don't have to do the extra work. So here you can think about breaking this function out to a second function that allows you to just do the prefix sum that way. And if you do the prefix sum, then now you have to only optimize this part, which I'll get to in a second. But the way that I did it is by having a second function, right? Now let's copy and paste this part, my notes for a second. Hang on. So the count smaller is the same, but now we have a second function. Because now we have a second function that allow us to have a number of possible lists of integers where we don't have to care about now. So this is basically let me think about how to say this. Number of possible lists of integers of prefix string nums of in a prefix sum kind of way, right? So basically the idea is that, okay, here instead of, so in this case, you can think about this case as, okay, now we broke it down to two scenarios instead, right? If upper is not, so here take a number of length upper, right? So this is basically what happens if you take a number of length upper, and here we take a number of length upper minus 1, right? Or number of length minus take a number of length minus 1, at most length minus 1, and here this is the number of possible list of integers of the prefix string where the next number is up to length upper. So this is a little bit awkward way of saying it, to be honest, and I agree. The reason why we did it this way, and this takes a lot of experience, or at least some experience, maybe not a lot of experience, but you can think about this way as a loop of a prefix sum loop. So as we talked about earlier, here we want to basically do a prefix sum, and this is kind of a way to do the prefix sum, because now we're doing it inclusively of all the possible counts, where you don't have to worry about the length anymore, right? You don't have to do that for loop, because now you can get rid of that for loop by assuming that every possible number that you can take is valid. So now here you have two options, right? You can either take a number of length upper, which is this one actually, sorry, or do not take a number, try a smaller length, right? So this is the case where we don't take a number, so now we try a smaller number, which is upper minus 1, and then here we take a number of length upper. So this makes sense, and here you can notice that we call actually this other function, because now you do care about the size again, right? Here, this is where we don't care about the size, because they are all valid. And here we do care about the size because it may be invalid, right? So you have to do this thing. So, okay. So now, this is going to be good enough. This is a little bit awkward because you may ask yourself, okay, sorry, let me step back for a second. I would say that if this loop dynamic programming, so this is actually a common thing. If you do try to do prefix sum, I recommend trying to do prefix sum, solve a prefix sum problem using top down. And if you're able to solve a prefix sum problem using top down, then if you're able to solve a prefix sum problem top down, then you're able to see, and if you practice enough, you'll see why this loop compression works. But this is how I think about it, right? But in terms of complexity, actually this is kind of interesting. The complexity, you can naively say, okay, for each possible input, we do O of n work because this is O, this is O of 1 because you do this, dynamic programming thing. Here you do, this is O of n, right? So that means that the total complexity of n is n cubed, but the total space is n squared. But actually, what if I told you that this total complexity is n squared? The reason is because you can actually amortize this over all n's. No, wait. Well, no, I think it's just, no, I lied on this one. It is just, okay, so this complexity is still n cubed, but this is going to be really fast because because string comparison in Python is just very fast. Because sorry, I lied a little bit. This is I think that I thought that there may be an amortization thing, but actually I think I'm wrong there. But yeah, so this is still n cubed, and this is n square, but this is really fast in Python because it is very fast. That's basically the short story. And if you did this, this is actually good enough to pass, even though it is a little bit slow. But like I mean, it is fast and it'll pass, but it is that the complexity is very awkward for this one for sure. Okay, so then how would you get rid of this, right? Well, the way that you get rid of this string comparison is by using dynamic programming. So, okay, so this is exactly the same code, except I use cache for readability, but that's fine. Everything else is the same. Oh, one more thing is that the base case is that if the number of digits of the previous digit is greater than the number of digits you have left, then you just have 1 plus the number, here we don't care about the digits anymore, so we record this, so that's how you get the base case. But again, the idea is just that you have a function where you don't care about the length, and then here, once you take a number, you care about the length again, which is why you get this dynamic programming. So yeah, so now the idea behind the next optimization, and I can copy and paste this thing again. Again, this actually times out, just to be clear. So you have to optimize this cache by writing it using by converting it to array. Once you convert it to arrays, it should AC in Leetcode, at least as of this writing. They may add more test cases, who knows, which I'll talk about in a little bit though. So in this case, yeah, I convert this to a function, and basically this function will just, convert this to, make this all of 1, right? And how do we make this all of 1? Well, we use dynamic programming. So actually, in this case, we don't use the dynamic programming here because there are too many subcases, right? Because if you think about it, index 1 can go from 0 to n. I2 can also go from 0 to n. L can also go from 0 to n. So if you use dynamic programming here, you will use all of n cubed space, and this is too much space. Yeah, even though I think it'll be fast enough because there are not that many possible inputs, but one thing to note is that, okay, so how do you calculate? So let's say this is the two numbers of the same length, right? So what does that mean? That means that, okay, you're doing 1 digit at a time. 1 digit at a time until you have the same, until you find a place where they're not the same, right? So let's say we have this magical function where we get the length of the same digits. You can kind of look ahead to see here, but let's say we have that right now, then we can go through it, which is that if the number of digits that are the same is greater than length, we return true, because that means that it's equal to, if we only care about length L and they're the same up to that much, that we return true, because this is actually a lie of the function name. This is smaller or equal to, right? Because it's non-increasing, so we return true. So you're going to think about this as non-increasing, though now the code doesn't work because I have to update it here. I guess that's actually it. Okay. So now this is a better name, right? So if we use up all the length, we return true because this is non-increasing. If we ran out of space on the, this is just basically if we ran out of length on the index 2, which I don't think should happen, to be honest, but I just put it in just in case, then it's false because that means that the index 1 has a longer length. And here, now we just look at, we compare the next character. And this is pretty basic. If the next character is smaller than or equal to, we return true. Otherwise, we return false, because that's the first character where they differ. And of course, now we can just, this actually, if you do not cache, if you do not memo, this will be O of L time. But because we do memo, this is O of 1. And if this is O of 1, then everything else you can see is just O of 1, because, for example, this is just one character, right? So then that means that this is O of 1 time if we memorize. And here is our get same function. This is just, again, the same idea with the prefix sum, kind of, in that we basically have a loop that we memorize a loop, right? If we get to the end of the string, we return 0. If they're not the same, then we return 0. But otherwise, they are the same, and you move one character. So basically, this is just get the number of characters that are the same, starting at x, y, right? So that's basically the idea. And here, that means that, you know, this is O of n squared space and O of n squared total time. Sorry, let me step back. Total number of possible inputs. And so this is O of n squared time, because this is the number of inputs times the work per input, right? Okay, so now that we made this O of 1, then now this is O of 1, right? This is now O of 1. And in this case, that means that the total complexity is n squared and total space is n squared. So in Python, this is barely fast enough. This takes 8 seconds. If this was too slow, I would make this bottoms up. This should make it a lot faster. I would make this bottoms up as well. So yeah, so you can make the bottom ups to go faster, but to be honest, I would just use another language as well. Maybe C++ to kind of do this. Yeah. I would say this was a very, very hard problem, because even the explanation took about 28 minutes. Let me know what you think. And yeah, you can watch me solve this live next. But one more note is that I think this problem is just very poorly written, because for n is equal to 3500, you have to do a lot of work to make it pass in Python, where if you use C++ or Java, you don't need a lot of the optimizations that I did, or like you don't have to rewrite this with bottoms up or whatever. So I don't know. It's just like very tight on the bound, right? Anyway, this is what I have. Let me know if you have any questions. Leave it in the comments. Come on the Discord. This is a very hard problem. It took me half an hour to explain. Hope the progression makes sense. And yeah, even just recording this and knowing the solution, it took half an hour, right? So anyway, you can watch me solve it live during the contest next. Let's see if I can do this one. It seems like a mess. What's index cube is going to be too slow. index index square, is that fast enough? Because the length of the previous number is always fixed, so then it's n square. But 3500 is such a tight n square though. I know it's not done yet. I'm just looking to see if it makes sense. Oh. That actually should be right if we get the right number, so that's maybe a little bit wrong. But also, this is clearly n cubed, so we have to figure out how to do it in a smarter way. Maybe I don't know how to do this one though. I was hoping this would be right. And this is a mess for me. But mostly on this one. And I knew how to do it, that's the sad thing. I don't know how to do this one though. So I don't know. This is going to be painful. That really should have been so silly. I am really bad today. Oh man. Do I know how to do this one? Now I could focus fully, but now I only have half an hour left, so. Why is this only 100 though? This should be Fibonacci, right? No, maybe? No, maybe not. Well, this doesn't work for 0, but I didn't do anything to make it anyways. Oh, all numbers have to be positive. I actually missed that part, so there's an additional thingy, but that's still, that's okay. How do you have 4 for this? Yeah, I don't know how we could get 4 from this. Maybe we gotta start from there. Oh, this is just clearly wrong. Why is this 0 though? Okay, so now I get the 101 because I forgot the entire string, which makes sense. And somehow this fixed the 4. Why was this 4 when that was not? Maybe I was just looking at the wrong number though. Okay, so maybe I was looking for this one. Okay. So now I'm confident that this works, except for it's still n cubed. I think this is actually the answer, but like I said, this is n cubed, so that's not going to cut it. Still pretty fast, but that's only because n is 100. Yeah, this is going to time out. And the question is, how can I do this in a smarter way? I have half an hour to figure this out. We could look at things a digit at a time, maybe. I think I have a good idea, but I don't think it's enough. Also in Python it may be too slow in any case, but Don't really have any ideas. $20 can I do in 20 minutes? It's dynamic. Well, if it's dynamic programming, I should be able to code it, but I just don't know. And people took a long time. Even smart people took a while. So, there must be an observation that I need to make. And one is the digits one, but how to? That's n cube. I don't know how to do it. That's not n cube. Also, I don't know how this got time limit. Oh, it's time limit because I kept this in, but. Just trying to see if I can maybe see a pattern. Makes it easier if I look at it backwards. Maybe not. Maybe it is. Maybe backward is the way to go. I don't know. this is just not right, so that's unfortunate. Not even faster. It's fine. Yikes. Why is this one? No, this is wrong. No, this is right, maybe. I have 7 minutes, but I'm probably not going to get this. I don't know how to do it, so. And even this is probably too slow anyway, so. Yeah. This isn't even right. Usually at least I get it right. I'm off by 1 or something. No, this is this plus 1, that's why. Okay. Okay, I was just being dumb. Maybe that is the story of today. Me being dumb. It's gonna take too long. I think there is a way to optimize this, but into 2 things. One is to basically just these two scenarios. But I don't know how to optimize this particular piece. It is not in a for loop. I think there's probably a not closed form, but a easy way to optimize for this. Yeah, that's just prefix sum actually. I think I don't have enough time to kind of think about it in a good way. Maybe. GG. I actually think if I didn't mess up on Q3, I would have had a very high score. Because I think I would have gotten like top 100 or something. Actually, that's kind of sad. But sometimes you just have to. What a silly mistake on Q3. I focus Larry. Still have a couple minutes. What's over 300? I'm just curious. So even 300 is too slow. So I need. I think I have an idea, but I don't know. I definitely don't have time to do it, but. Something like this, maybe. But I don't think this is right, but yikes. Oh. Oh well, I don't know how to do this. Okay, so this is the part where I do code reviews, I guess. I guess 235 is not that bad considering. But let's do some code review of Q4, and yeah, let's see what's the way to do it. I really should have gotten Q3 though. Q3 was sad because then I would have gotten pretty good score actually. Okay, this code is. I'm just looking. I mean, it seems like it's DP, but yeah. But try to figure out what the thing is. Okay, I think I actually had the right idea. I mean, this is basically what I was maybe doing. All right, this is just too much. Yeah, I think this is actually what I was trying to do at the end, but I didn't get to finish it. Because this would be n squared for sure, but it's just wrong, obviously. This recurrence is a little bit off. Yeah, this recurrence definitely is a little bit off. So, but in theory, that's how I would do it. Let me see if I could debug this at least a little bit. Yeah. Okay. I mean, this is an answer. It's not the answer, but it's one answer. That's good. Oh, wait, no. Okay, so it's not the right answer, but it's... Do I want to say it's close? I don't think so, but I think I'm just off by a little bit here. And this thing is a little bit sketch. But, well, that's actually, we can actually test this, right? We can have the number. So I guess this part is still gonna make, and you have to make it so that, so you have to cache this part as well. I think that's what it is. You have to do this part in a smarter way. But, what's the intended answer? Is that the right answer at least? Oh yeah, there's no way that's the right answer because Well, I mean, it may be the right answer, but they're not going to know because this input doesn't make sense. It takes 5 seconds, so that means that I am definitely not doing anything right here. Let's just at least see if this is right. If this is okay, so this isn't even right. So okay, that's fine. I'm far off by some weirdness here. Let's see if I can learn to do this before I do it. Yeah, just gonna post this on my Discord real quick. Okay, let's see if I can figure out a good learning solution. Oh, maybe this is really. I don't. Well, I mean, if it requires a suffix array, then maybe I am okay with giving up. Only 41 people solved it. That's tough because I don't think I got in 12 minutes, but even like if I got in half an hour, I would have gone top 100. So that's where I probably could have been, but I was a little bit of a mess. Made a silly mistake. I mean, this is clearly suffix array stuff. Is there a way to do it without suffix array? Because I think if the only way to do it is with suffix array, then maybe it's okay. Wow, this is a clean solution. I just have to understand it. Oh, I mean, this is what I had, but I just didn't know how to do this in whatever time. And I had this kind of. I mean, that's what I was trying to do here. I think I had the right idea. Maybe I can't do it top down. Maybe. I don't know. Okay. I think I'm gonna try to solve this offline. Yeah. This is a hard problem for sure. Oh. No, he just did it top down. So let's see. Well, I guess not. Did the comparison top down? Can you do the comparison top down? I guess so. I was trying to figure this part out too, but thanks for watching, everybody. Hit the like button, hit the subscribe button. Join me on Discord, especially if you like contest problems and stuff like that. There are a lot of smart people there, and also me. So yeah, stay good, stay healthy. I'll see you next problem, and to good mental health. Bye bye.